Hello everyone, my name is Wu Shaoji from School of Architecture, Tianjin University. Today, my presentation's topic is Approach to Auto-Recognition of Human Trajectory in Squares using a machine learning-based method. There are four parts in this presentation. The first part is introduction. At firstly, I'd like to introduce you the background. The squares play an important role in contemporary urban space. Researchers have explored ways to derive a more favorable square layout through the distribution of people. However, traditional methods such as recording people's distribution through human visual inspection cannot effectively reflect people's location in squares due to their high human cost and low accuracy. This paper proposed a deep learning-based method to derive the distribution of people in squares accurately and takes three squares within the Tianjin University campus as example. And in this figure is the technical roadmap of this paper, which can be divided into the following three steps. The first one is the acquisition of videos and the method of obtaining human trajectory from it. The second one is cleaning the raw human trajectory data. The third part is to visualize the trajectory data. This figure shows the three research examples, all of which are located on the campus of Tianjin University. In this study, these three examples are referred as A, B, and C. The second part is methodology. The UAV device used in this study is DJI Mini 2, which captures 4K video as base data for analysis. And this study used the deep learning-based YOLO version 3 and DeepSORT algorithm to calculate each person's trajectory in this video. This section is programmed on the Python by TensorFlow and Keras as machine learning package and OpenCV as a computer vision package. This section can be divided into the following three steps. The first one is obtaining human trajectory data by using UAV. The second part is transfer learning. We use the transfer learning approach to training the neural network to recognize pedestrians in squares. Transfer learning is an approach used to transfer information from one machine learning task to another. In this study, we transferred the YOLO version 3 parameters downloaded from the official website into a model that can recognize people from the top view. This picture shows the YOLO version 3's neural network. The first part is import frame or picture. The second part is convolution and pooling. And the third part, we output predict boxes in three different scales. And the last part is the result. Then we use DeepSORT to track people passing through in the entire video and obtain their trajectory based on an octave vector U, V, R, H, X star, V star, R star, and H star, where X star, V star, R star, and H star is the velocity of U, V, R, H between two adjacent frames. And after we get the raw trajectory data from the algorithms, and we use boxing and box plots to clean the data in this study. And the last part is visualization. The third part in this study is analysis. The trajectory data of example A mainly connects the entrance and exit and surrounding buildings entrance with the densest pedestrian path connecting the northwest and southeast entrances. An analysis of pedestrian speed shows that square A have a clear area of high-speed distribution connecting the northwest entrance and the southwest entrance. The high-density pedestrian paths in example B are the southern and western passes with less pedestrian traffic on the northways. The fast pedestrian passes in this case are mainly located on the north side. And example C is a symmetrical layout with 3 entries and 3 main passes. However, there are only 2 paths that people walking through, one connecting the north and south entrance and the other connecting the east and north entrance. In contrast to example A and B, there is no high-speed path on this square. By comparing the spatial phenomena by the distribution of pedestrian trajectory in the 3 examples, we can find the following 2 points. Firstly, the intensity of connection between the entrance and the exit around the square can be characterized using people's distribution heat map. Secondly, the people walking speed heat map characterized pedestrians' spatial distribution with different velocities in squares. And the last part is conclusion. There are 3 conclusions can be drawn from this paper. Firstly, it is found that human trajectory data derived from this method is more accurate when the UAV is flying at a lower altitude. Second one is this study demonstrates that a passive real-time locating system (RTLS) based on a deep learning computer vision algorithm can effectively obtain human trajectory data in square. Third, this paper proves that the visualization method we used is effectively. And that's all. Thank you.